Okay, so pleasant good afternoon to all of you signed in to the 2021 hurricane season forecast. My name is Esther Lambert, Research Associate with the Institute for Catastrophic Loss Reduction, and I'll be the moderator for today's session. Just a few notes before we begin. Please don't hesitate to post your questions. Any questions you may have during the presentation, you can post those in the Q&A box at the bottom of your screen. Also, if you have any technical difficulties or have any questions about any technical issues, send us a message using the chat box at the bottom of your screen as well. So the topic of hurricanes and the serious threat that they pose is definitely a topic worth our attention. Definitely for forecasting itself has an important role in helping communities prepare. So now that the Canadian Hurricane Center is coming up to 35 years in existence, Canada has really come a long way with hurricane forecasting. And so we're really excited today to welcome back Mr. Bob Robichaud, who's a warning preparedness meteorologist with the Canadian Hurricane Center. Mr. Robichaud received his BSc in meteorology from Lyndon State College, Vermont in 1995. He's worked in the private sector as a weather forecaster and then joined Environment Canada in 1998 as an aviation forecaster. And in his current job, he works closely with emergency management officials. So we're very happy to have you back, Mr. Robichaud, and I'll pass it over to you to give your presentation.
All right, thank you very much, Esther, and welcome everybody to this year's hurricane briefing for 2021 after what was really a record-breaking season last year in 2020. So what I'm going to basically talk about today is I'm just going to do a quick review of tropical cyclones, since we only have to deal with these storms over a certain time of the year, and then go over some in a bit more detail, some of the hazards associated with these storms. We'll do a review of the 2020 season, and then we'll look at what we might expect for this upcoming hurricane season. So in terms of what these storms are and what is needed for a tropical cyclone to develop, there's a number of things that we require. And really the building blocks are things like a disturbance in the atmosphere. It doesn't have to be a closed circulation for something to develop, but it has to be a closed circulation to be classified as a tropical cyclone. So, but it usually starts off as a disturbance, some kind of rotation or spin in the atmosphere. It also, whatever that disturbance is, has to be located several degrees north of the equator. Otherwise, there's not enough Coriolis force to increase that spin to get that close center of circulation that you need. Also, there has to be very little change in wind speed and or direction with height. So something we call wind shear. So as you go up in the atmosphere, the winds have to remain fairly constant. Once you have those building blocks, then you're looking for the fuel. So in that, the number one fuel for hurricanes are the warm waters of in the tropics. So we need water temperatures that typically are fairly deep and at least 26 degrees Celsius. We also need an unstable atmosphere. So when you go up, not only do the winds need to be fairly uniform, but it has to get progressively colder at a sufficient rate as you go up in the atmosphere to result in an unstable condition. And then the last thing that we need is high relative humidity. So, relative humidities that are close to 100%, high dew points, that sort of thing. So once you have everything in place, then you have the potential for a tropical cyclone to develop. And this is the just a map representing all the tropical cyclones all the tropical cyclone tracks globally. And you can see certainly the Pacific and Atlantic are very active. Notoriously, there's not a whole lot near the equator because, as I mentioned earlier, there's not enough spin there to really get these storms going. Now, if we look at Canada, again, there's not a whole lot, if of anything, really, on the west coast of Canada. Most of the activity that we see with respect to tropical cyclones in Canada are Atlantic in origin. So we're going to focus on that a little bit more today, and as we go through the last year's season and this upcoming season. So the season officially starts next Tuesday. So June 1st is the first day of Atlantic hurricane season, and it extends all the way into the end of November. But really, once you get into August is when things really start to ramp up, and we tend to get more storms climatologically in that period of August, September, and October, with September being the peak of hurricane season. And if we look at some of the hazards, we'll start with the wind because that's how we classify tropical cyclones in terms of its wind speed. So once it's declared a tropical storm and the winds, that means that there's a closed center of circulation. The storm has a very specific structure and the winds are at least 63 kilometers per hour. That's when we give it a name. So if that storm is allowed to strengthen and the winds reach 119 kilometers per hour, that's when it actually gets called a hurricane. It keeps the same name, but it gets classified as a hurricane. And then, of course, 3 categories of hurricanes, depending on the different wind speed. Now, one of the things that we find here in more northern latitudes is these tropical cyclones go through a transition to something from a structural point of view, looks more like a winter storm. So we call that extratropical transition. So that transition can take 12 to 24 hours, and the resulting storm is a post-tropical storm. It still can be a very potent storm, but it's no longer the warm water that fuels the storm. It's rather the temperature differences between northern and southern latitude. So when we have a storm that actually becomes post-tropical, there's a number of things that we know happen to these storms. First, they increase in size, they speed up. So when the storm is approaching, it's usually going a lot faster than when it was a pure hurricane. So what happens is if you look at the overall wind associated with a tropical cyclone, you have to take into account both the circulation around the center and also the forward motion of the storm. Now, when a storm is moving in the tropics and moves a lot slower, there will still be a slightly higher wind on the right-hand side of the track. But since the storm is going slow, and typically 5-10 kilometers per hour is typical for the tropics. But when you compare that with winds of 150, even 200 kilometers per hour, very little difference from one side to the other. However, when you're looking at a circulation that is maybe about 100 kilometers per hour, but a storm that's moving about 40, 50 kilometers per hour, that difference becomes way, way more pronounced. And we tend to really get a big difference between the winds on the right-hand side of the track versus the winds on the left-hand side of the track. So the winds are typically stronger on the right-hand side of the track. They can be strong on both sides, even in our latitudes, but typically we see the strongest winds on the right-hand side of the track. And if you want to break it down a little more even, you're looking at most of the storms that over 50% of the storms that enter our response zone, the strongest winds will be in that right rear quadrant of the storm. So usually that's over kind of the southeastern part of the storm where we tend to measure our strongest winds. In terms of rainfall, we know that these storms produce a lot of rainfall. Often it's not just the total rainfall, but it's the rainfall rates that kind of overwhelms the different infrastructure that we have. Rainfall rates in tropical cyclones can easily reach 20, 30, sometimes up to 50 millimeters per hour. And sometimes it's not necessarily a pure tropical cyclone that will result in flooding up in Canada. Sometimes we can have a different type of storm that basically entrains moisture from a tropical storm, and you tend to have this stream of moisture from a tropical system that feeds into a different system, resulting in heavy rainfall as well. We've seen numerous examples of that over the years. And there are different factors that dictate the amount of rain you're going to get, the size of the storm, the speed, so the motion of the storm, the rainfall rates at a particular time, the duration, and then the stage of transition to post-tropical is also going to dictate where the rain is. If it's just starting that process, you're going to have heavy rain on both sides. If it's towards the end of the process, you may not have any rain on the right-hand side, but all your rain will be on the left-hand side. So you end up with your heavy rain on the left-hand side and your strongest winds on the right-hand side. Storm surge is also a very significant hazard that we see with tropical cyclones. Storm surge is essentially the storm itself, the low combination of low pressure and the wind that forces the water onshore, causing flooding situations. And then another thing that we have with these storms, of course, are waves. But there is a particular phenomenon that occurs when a storm goes through this transition to post-tropical. So something that happens in our latitudes that doesn't really happen even with a Category 5 hurricane that would be down in the tropics. And what we tend to see is just incredible wave heights with these post-tropical storms. As I say, something that you typically wouldn't even see with a Category 5 hurricane. So what happens is in the tropics, since these storms move fairly slowly, it of course creates waves over the ocean, but the storm moves so slow that the waves move out ahead of the storm. So a lot of folks that live down in the islands down there will say that they will tend to see the waves arrive prior to the arrival of the storm. So it could be a nice clear day, but they'll start to see the waves arriving before the storm actually arrives. And that's because the waves that the storm is creating are moving out ahead of the storm because the storm is moving so slowly. If you look at the example of a winter storm, they tend to move a lot faster. So the larger waves are just as the storm is pulling away. So some of the largest waves that you might see would be, again, towards the latter part of the impact of the storm. But now consider the situation where you have a slow-moving tropical system. It's creating waves that are moving out ahead of it. But now that storm starts to accelerate and it starts to increase in forward motion. What happens is that there is a certain part of the storm that stays in sync with the storm itself, with the area that is creating waves. That allows for a relatively small part of the storm over the ocean where the waves are allowed to build to those incredible heights. And you only see that because the storm is accelerating. So we've known this theory for a number of years, but that area within the storm is so small that it's rarely sampled. But since '95, it's been sampled a few times. So we know that this phenomenon actually exists. But most of the people that you will see going down to the coast to see the waves don't necessarily understand this phenomenon, and they could be swamped by a wave that's significantly higher than all the waves that come before it or all the waves that come after it. So very dangerous situation, and something that we pay particular attention to these storms as they move in our latitudes. So that's kind of a brief review of tropical cyclones. Now I'm going to talk a little bit about last season, and these are all the storms from the 2020 record season. Certainly very, very active from just prior to the season officially starting, right up until essentially the end of November. So if we look at some of the statistics from last year, and we see that there were 30 named storms. Of those 30, 13 became hurricanes, and of those 13 hurricanes, 7 were classified as major hurricanes. So category 3, 4, or 5. And you can see the predicted numbers from last year from NOAA. There's a variety of different agencies, I think about 27 or 28 agencies that actually try to predict the number of storms that you'll see in a particular year. This particular prediction was from NOAA. Basically the government agency in the US, and they were calling for 13 to 19 named storms. That prediction was ultimately updated in August as part of a regularly scheduled update, and they increased that higher number to 25, but even at that we saw more storms than what was predicted even last year. Even with those, the prediction of 25 named storms was the highest prediction they had ever made, and it surpassed even that. So the prediction was for active to hyperactive season, and of course we certainly had that. We look at the tracks of the various storms from last year, pretty much covering most of the Atlantic Ocean, kind of 2 clusters, one just near or just east of Bermuda, south of Atlantic Canada, and the other one, which seems to be more like a larger cluster in the Gulf of Mexico region. Closer to home here in Canada, we had 8 storms that entered our Canadian Hurricane Center response zone, which is basically crossing that yellow line. So we had 8 of them. 4 of those 8 were enough to trigger our Hurricane Center to issue specific bulletins on those storms. And excuse me, with 30 named storms, there's lots to go through there. I mean, we could spend a whole day just going through these various storms, but I did want to focus on a couple of them. And the first one is Isaias, which impacted the eastern United States, as you can see the track there, and then eventually into southeastern Quebec. So Isaias was the 9th named storm of the season, affecting the Caribbean, large portion of the eastern United States, and as I mentioned, into southeastern Quebec. All told, there were 12 fatalities, numerous injuries, but a lot of what we saw with Isaias was damage as a result of the wind, specifically all along the eastern seaboard of the U.S. So there were over 3 million people without power, some lasting for 2 weeks. And in New York, it was the largest power outage since Superstorm Sandy back in 2012. As the storm continued into New England and into southeastern Quebec, it resulted in 125 millimeters of rain and several thousand people without power there. All told, $4.8 billion in damage with Isaias. The next storm was Laura. Laura was a storm that developed off the coast of Africa, became the 4th hurricane of 2020, and then eventually became the first major hurricane last year with winds of 240 kilometers per hour. Laura was one of those storms that went through what we call rapid intensification, which is basically a nightmare for forecasters, a storm that intensifies very rapidly, and you can get into these situations where people go to bed at night and they're looking at an approaching tropical storm. They wake up in the morning and all of a sudden there's a major hurricane knocking at the door. And this was one of those cases where it went through rapid intensification just before making landfall in Louisiana. Now the peak storm surge was a big deal with this storm. It peaked at around 5.5 meters above ground level, so a very significant storm surge, something that we tend to see quite a bit along the Gulf Coast with these stronger hurricanes. There were a total of 41 fatalities in the US, but not one due to storm surge, which typically is the biggest killer in these storms, is the storm surge. There's a total of $19 billion in damage, and the storm got a lot of attention because of some of the language that was used in the warnings of the storm. So the folks at the National Hurricane Center in Miami actually included in some of their warning bulletins, they talked about unsurvivable storm surge, which luckily resulted in near 100% compliance in the evacuations for coastal areas. But that peak surge did not was not registered by any of the measuring devices used to measure water level. So there was a lot of kind of backlash towards the Hurricane Center in the hours and days following Laura, that the use of unsurvivable storm surge was a bit reckless. But it turns out that the area of highest surge was between some of the measuring devices. So as with any other storm, there is a pretty substantial storm survey that is done after the storm. And that entails surveyors and meteorologists going to different areas and determining how high the water got. And this is not right at the coast, but near the coast. And this was a two-story house, and you can see how high the water level actually got based on the stains in the bathtub in that second-story home. So it was estimated that that storm surge of 5.5 meters certainly did occur in those areas, which certainly would be unsurvivable if someone was caught in that. So it just goes to show, how good these forecasters are in Miami in predicting some of the hazards associated with that. Now, the next storm was Sally. Sally caused a lot of headaches for forecasters, as both the not just the track, but the intensity was fairly erratic. It fluctuated quite a bit. It ended up making a landfall in Alabama as a Category 2 storm, and resulted in 4 fatalities and $7.3 billion in damage with Sally. Now, by the time we got to Sally, which was mid-September of last year, we were already kind of dealing with the potential arrival of Teddy in Atlantic Canada. So a lot of focus was on Teddy. Meanwhile, there was another weak system that was crossing Atlantic Canada prior to a few days prior to Teddy's arrival, that ended up taking a lot of the moisture from Sally and pulled it up into that system. That resulted in heavy rain in eastern Newfoundland. And that map that you see of the island of Newfoundland and Labrador, that red area is essentially, this was part of a map that was tweeted out by the Newfoundland and Labrador Weather Office, and they were calling for 100 to 150 millimeters of rain. And they certainly got that and more. Up to 206 millimeters of rain fell in the Placentia area, causing what we typically see when we get those that kind of rainfall there. Basically, systems, culverts that were overwhelmed, roads that were washed out, and this is as a result of a storm that pulled moisture from the south that wasn't directly related to Sally. So it just goes to show that it's not always the direct impacts from a particular cyclone. Sometimes it's indirect impacts that cause the most problems. And then we had Teddy. Teddy was probably the most impactful storm that we had here in Atlantic Canada. It was certainly the one of the largest storms that we've seen quite some time in the Atlantic. It was also the storm that created the most energy overall in 2020. It wasn't the strongest storm. It was one of the strongest, but it lasted quite long. So overall, it ended up generating more energy than any of the other 29 storms in 2020. It actually went through 2 stages of rapid intensification. And then peaked at Category 4. It entered our Canadian Hurricane Center response zone on September 22nd. And the storm ended up interacting with another feature that was moving towards Atlantic Canada from Quebec. And then there was some additional strengthening just before it made landfall. And then it became post-tropical just before, about 12 hours or so just before landfall. And I mentioned earlier how these storms get bigger when they become post-tropical. This is the radius of the gale force winds associated with Teddy, and you can see the change in just a 12-hour period from 9 p.m. on September 21st to 9 p.m. To 9 a.m. on September 22nd. So the winds expanded significantly with Teddy, and as you can see from the satellite image here on the last page, the cloud shield extended all the way into New England and even up to Labrador, while the storm was still well to the south of Nova Scotia. So the peak winds with Teddy were 220 kilometers per hour. So that's, again, that's a Cat 4. Peak winds that we observed here in Atlantic Canada, there was 145 kilometers per hour in Cape Breton. Some of that is due to enhancement from topographical features. The peak non-terrain induced wind was 119 kilometers per hour in Cape Breton as the storm made landfall along the eastern shore. There was also heavy rain. Several locations reported over 100 millimeters of rain. Wasn't a whole lot of flooding reported, but we did certainly get a lot of rain. One of the main concerns that we had with this storm was the waves. Now, we did measure waves that exceeded 14 meters along the eastern shore, along parts of the eastern shore anyway, and there's some reports that from fishermen that it was some of the largest waves they had ever seen, even though they came in significantly lower than what we had seen the previous year with Dorian. So these are just 2 nice images from the Hurricane Hunter aircraft that were flying into Teddy just a day or so prior to the storm arriving in Atlantic Canada. In terms of rainfall, again, because the storm was so big, some of the rain extended far beyond the center of the storm. So it started early in parts of Cape Breton, which is why you see that 120 there. So some of that, not all of that, is directly related to the center of the storm, but is still kind of linked to it indirectly. But most of the rain that fell directly, tied to the center of Teddy, fell to the left of the track. And as I mentioned, several areas reported over 100 millimeters. In terms of wind, given that the storm tracked through the eastern shore, there was just a very small part of Nova Scotia that actually ended up in the area of strongest winds, and that's the area to the right of the track. So the eastern half of the eastern shore into Cape Breton got the strongest winds there. The other storm that I wanted to mention was Delta. I mentioned how there was 2 clusters of storms. One cluster was in the Gulf of Mexico, but this is a good example here. And basically, this storm formed just south of Jamaica, and again went through some rapid intensification, reached Category 4 status, made 2 landfalls, one on the Yucatan Peninsula of Mexico, and then re-intensified out in the Gulf of Mexico before making landfall once again in Louisiana, almost the exact same place that Laura made landfall several weeks prior to that. So there's most of the people there were still in the early stages of recovering from Laura when, lo and behold, Delta came along. And the picture you see there is just there's a sea of homes with tarps, blue tarps on their roofs, and of course, was no match for another hurricane like Delta. So Delta peaked at 220 kilometers per hour for the winds. Storm surge not as high as Laura, but still significant nonetheless, and $2.4 billion in damage with 4 fatalities. And then finally, we had Iota, which was the last storm of 2020, and certainly last but not least, because it was the strongest storm of 2020. It didn't last tremendously long, but it formed just to the east of Nicaragua, and then went over a patch of really, really warm water and went through explosive strengthening during its lifespan of about 5 days, and just prior to making landfall in Nicaragua around the middle of November. Peak winds were at 250 kilometers per hour, and Iota is responsible for causing 67 direct fatalities, and many more were missing. The report from Iota just came out last week. So there's still, the season was so busy that all the reports for all the storms are not even out yet. They hope to have them all ready by the start of the 2021 season, which is next week. So hopefully within the next few days, we'll get the remaining reports. I think there's Laura and maybe one more that's missing from the list. So because Nicaragua was impacted by another hurricane just weeks before, just like Louisiana, the damage estimates were actually fairly low at $1.4 billion because everything was already destroyed from the previous hurricane. So a lot of areas last year got affected by multiple hurricanes, which is extremely devastating, as I'm sure you can appreciate. So if we look at the storms, the distribution of storms over the course of the season, we had a couple develop in May prior to the official start of the season, and then a couple in June, and then you can see how things really ramp up once we got into August and September. And if we look at hurricane season from last year by the numbers, certainly the hurricane hunters were busy with 86 missions, 102 eyewall penetrations, and close to 1,800 drop zones that were dropped in the various storms from last year. So we had a record of 30, that record of 30 named storms beats the 2005 record of 28. 8 named storms entered our response zone, which is not a record, but is close to it. It was the 6th straight year that we had storms form prior to the official start of the season. The 5th straight year that we've had above normal storm activity. We had 12 storms hit the U.S. coastline, which was a record. There were 10 storms that formed in the month of September alone. And if you look at last year, the average number of storms in a season was 12. So almost the average number of storms for an entire year, or entire season in 1 month. We had an amazing 10 storms that went through rapid intensification, just amazing. And all told, $51 billion US in damages and 442 known fatalities. So clearly, 2020 is just an amazing hurricane season. You know, with all respects, from the meteorology to the impacts, just one that will be, and of course, through all this hurricane season, this record hurricane season, in the midst of a global pandemic. So certainly something notable there. So with 2020 behind us, what might we be looking at for 2021? Well, the the factors that influence a hurricane season don't really change from year to year. It's the same factors, but it's the contributions from these factors that tend to change. So we look at a number of things. Some of the main things we look at is the water temperature in the Atlantic. So I mentioned that we need water temperature of at least 26 degrees. That's usually not a problem in the tropics, especially in the summertime. And we look at whether there's a lot of wind shear in the tropical Atlantic as well. And then the other thing we look at is whether we're in an active or inactive phase of what we call the Atlantic Multi-Decadal Oscillation. And I'll talk a little bit more about that. So let's look at these three factors. This is just a representation of water temperature anomaly in the Atlantic as of just a few days ago. And you can see that there's a fairly large area of warm water in kind of the northern tropical Atlantic, but in the actual tropics, the water is actually a little bit colder than normal. That is right now, that is in May. But we expect that by the time we get well into hurricane season, the water temperature there will be near or certainly near, but probably even a little bit above average. So we expect warmer water in the Atlantic once we get into the core of hurricane season. If we compare that with what we had last year, that area of colder water was certainly much smaller than it is this year. So a much larger portion of the Atlantic was warmer at this time last year. So there's that factor to consider. The other factor is wind shear. So we try and figure out whether there is going to be more wind shear than average, or about the same, or less than average. Obviously, as I mentioned in one of the first slides, is you don't want a whole lot of wind shear if you want a hurricane to develop. Now, wind shear in the Atlantic is very closely tied to whether we have an El Nino or its opposite counterpart, the La Nina. Last year we had a La Nina, meaning that, and what we look at for that is water temperature in the equatorial Pacific. So in that area off the coast of Peru, what we look at is water temperature. If the water temperature is higher than average and above 0.5 above average, then we call that an El Nino situation. If the water temperature is colder than minus 0.5 below the average, we call that a La Nina. And anything in between is called a neutral situation. So currently, we just exited the La Nina that we were in last hurricane season. So that's only as of a couple of weeks ago. So we're now in a neutral situation, and all these lines depict the temperature anomaly in that area off the coast of Peru. And as you can see, most of the models have a continued warming from where we are now, but more or less stabilize once we get into the peak of hurricane season, which is that dashed area there in the middle of the map of the graph. So we expect that once we hit that August, September, October timeframe, that we will be, most models indicate that we will be still in a neutral situation. So if we break that down, there's a 55% chance that we will be in a neutral situation in the core of hurricane season, and only a 21% chance that we'll have an El Nino. So basically what that means is that we're not expecting a whole lot of wind shear above what we typically get in the Atlantic for this year. So that's the other contributor to the overall season. And the last one is this multi-decadal oscillation. There's a lot of talk about about this particular phenomenon in the last year or so, but basically what we look at is these active and inactive phases of hurricane activity. And we can certainly determine that there are periods that alternate between active and inactive. And we've been in an active phase of this since 1995, which correlates very well with the higher than average hurricane activity that we've seen in that period, in that same period. So there's no signs that we are exiting the active phase. So because of that, we expect that this will have a positive contribution to hurricane formation once again this year. So if we look at all three of them together, we expect that the water temperatures are going to be warmer once we hit September, October, or August, September, October. We don't expect a mitigating impact from more wind shear, but we don't expect that there will be as little wind shear as there was last year. And finally, we're still in that positive phase of the multi-decadal oscillation. So what does that mean for the predictions for this year? And NOAA just came out with theirs actually a week ago today, and they are calling for 13 to 20 named storms, where the average over the last 30 years is 14, 6 to 10 hurricanes, where the average is 7, and 3 to 5 major hurricanes, where the average is 3. So they're only really looking at about a 10% chance that the season would be below normal, and 60% chance that it would be above normal. So essentially, we expect this to still be an active season, but less active than what we saw in 2020. So what does that mean for Canada? If we look at the number of storms that form in the Atlantic and compare that to the number of storms that enter our response zone, typically we get about a third of the total number of storms that enter our that form in the Atlantic end up entering our response zone. And we've been tracking that since the inception of the Canadian Hurricane Center back in '87. So another way to look at this, and this is something that Colorado State University does, they look at analogs. So they look at the current conditions and what type of conditions might we expect with respect to the wind shear, to water temperatures, to whether we're in an El Nino or La Nina situation. So they look at things now prior to the start of the season and compare that to similar situations for other hurricane seasons. And they come up with a set of analogs. So years where they look very similar to this year based on the current and expected conditions. So they've come up with 5 different analog years to 2021. So 96, 2001, 2008, 2011, and 2017. So look at the first one here, 1996. We had 6 storms that entered our response zone that year. Bertha was a rainmaker with close to 100 millimeters of rain. Edward was another storm. We had Hortense, that was the first hurricane to make landfall in Atlantic Canada in 21 years. With peak winds of 161 kilometers per hour. That was 96. 2001, again, another fairly busy year for us. We had 7 storms that entered our response zone. 2 ended up making landfall. Gabrielle was a particularly heavy rainmaker along the Avalon Peninsula of Newfoundland. And at the time, the mayor of St. John's called it the worst storm in 100 years on the Avalon. 2008, again, another busy season for us with 7 named storms that entered our response zone, including 1 hurricane with Hurricane Kyle. Post-tropical storm Hannah was another storm that crossed Nova Scotia, but resulted in very heavy rain in the St. John area of New Brunswick and into the Moncton, and then eventually into the Charlottetown area, causing some flooding there. And And then 2011 is another analog year. Again, very busy year for us. 10 storms entered our response zone. Irene was probably the most impactful one, causing significant flooding in all of New England and into Quebec as well. And then finally, 2017. Now that was a particularly bad year. That was the year of Hurricane Harvey and Maria and Irma. However, we fared pretty well in terms of impacts. We didn't get any significant impacts from any tropical cyclone that year. So, but 4 out of those 5 analogs, we had impactful storms. So that's another thing that I like to look at to kind of give us an idea of what we might expect this year. So the list of names that we're going to be using is going to started with Anna. So we had Anna, subtropical storm Anna, that formed over the weekend. Again, very, very short-lived storm. The next storm on the list is going to be Bill, followed by Claudette, Danny, and so on. And then one little change from previous years is only twice in the history of the Atlantic hurricane season, we ran out of names and we had to go to the Greek alphabet that we had at the time up to this year. So we did that in 2005 and again last year, but we noticed some issues in doing that because we had a number of storms that we had to retire last year based on their impacts, and some of them were from that Greek alphabet. And then we had other storms that sounded very similar, Eta and Theta, and some of those storms were occurring at the same time, so it caused some confusion. So rather than do that and proceed with using the Greek alphabet, what we're going to be doing from here on in is if we do run out of names, is go to a supplemental list of names that we can use, and it's constructed very similarly to the other 6 lists that we use. But if we're in a situation where we have to retire one of these names, we can just retire it and replace it with a corresponding name with that first letter of the alphabet. So that's one thing that's going to be different from this year, but hopefully we don't get into a situation where we run out of names 2 years in a row. So finally, to get the latest information, the National Hurricane Center in the US, they have all the information on the various storms, on the various areas that they're watching for potential development. If a storm shows signs that it may impact Canada, that's when you can start incorporating information from the Canadian Hurricane Center. And our website is hurricanes.ca. If you haven't done so already, certainly download our weather app. All our hurricane information will be available on there as well. And we've progressively tried to put more resources in managing our Twitter accounts. So both the French and English Canadian Hurricane Center Twitter accounts have been more active in the last 2 years. It's only existed for 2 years, but it's been progressively more active, and we expect that we will add to that again in 2021. So with that, like we always say, it doesn't matter what the total number of storms are that form in the Atlantic. What's important is the one that actually affects you. So it only takes one storm to make it a bad year. So with that, I'll wrap it up and open it up for any questions.
Thank you so much. Thank you, Mr. Robichaud, for enlightening us. This was very informative, and we do have a few minutes for questions. So I'm just reminding our attendees to post their questions in the Q&A box at the bottom of your screen. But I could start us off with a question that's sort of regards to coordination of efforts when it comes to warning systems, considering a lot of these systems come from they've already passed through further south and they're coming towards Canada. Could you maybe give us an idea, walk us through some of the emergency management process in terms of communication between the Canadian Hurricane Center and other hurricane centers and emergency management officials in the South?
Right. We work very closely with our partners in the U.S. at the National Hurricane Center. We're part of the World Meteorological Organization committee that oversees hurricane procedures in the Atlantic. So we work very closely with them. We send two of our forecasters down to their center every year for some training and that sort of thing. Last year was a very, very interesting year where we were able to use some of the technology that we have to interact in real time as a storm is approaching. So there was very good communication between the Hurricane Center in Miami and the Hurricane Center here. In terms of our emergency management partners, we work tremendously close with them as well. I actually have an office in the Nova Scotia Emergency Management Office, and I work out of that office. When a hurricane is approaching, we always talk on a daily basis anyway, but being embedded within the emergency management agency really allows you to give them a really good heads up on when a storm is approaching. So even when it just starts to form, we have a pretty good idea what is going to end up happening with that storm, whether it's a storm we need to watch or a storm that is predominantly going to affect another part of North America. So we can start those discussions very, very early in the process, which helps tremendously in ramping up the preparation for these storms when they do impact us here in Canada. So we work very, very closely with our emergency management partners on a daily basis on anything that is approaching from the south.
Yes, I can well imagine the challenges that would present. Would you say some of the major challenges that are presented in that kind of situation?
Yeah, for years I've been kind of saying that some of the bigger challenges is in the communication aspect of the particular hazards. It's not necessarily the forecasting of the storm, even though that can cause its own challenges. Mm-hmm. It's taking that information and communicating that so people understand what the risk is. We had people last year, even though we were constantly saying that we weren't expecting the impacts from Teddy to be as strong as the impacts that we saw with Dorian in 2019. Yet a lot of people, they went out and purchased generators, and which is good, but they were doing that based on what they thought was going to happen with Teddy, and their idea of what they thought was going to happen with Teddy was based on what they experienced the previous year with Dorian. One of the other aspects that we were trying to get across pretty much at this time last year is that any kind of preparation for the hurricane season, if there was any year to do that early, it was last year and this year as well, because we're in a global pandemic. And sure enough, when Teddy was coming up the coast, we had lines of people trying to get propane for their barbecues. So those people clearly were not ready during the course of the season for a tropical cyclone. So it's that communicating the hazards that's a bigger challenge almost than the actual forecasting of it.
Yes, definitely. We know that personal experience, past experience definitely affects people's response and their behavior. Mm-hmm. I do actually have one more question with regards to subsystems that form within the system. So I'm sure you would know Tropical Storm Erica really heavily impacted the Caribbean island of Dominica and other islands as well. And what happened was, as the system approached the island, a subsystem formed over the mountains and remained stagnant there and caused a lot more rain than a lot of the meteorologists expected it to form. I'm just wondering whether Canada experiences similar situations and whether the center has a way of catering for those types of things, if even possible?
Yeah, I think, and again, I think that goes back to communicating the hazard as a whole rather than the specific weather, the expected weather event. A good example of that here in Canada was the moisture from Hurricane Matthew from a few years ago. Uh, for a number of days, we were watching that potential, the potential for that moisture to feed into another weather system that was predicted to stay just offshore. But the night before, the system moved a little bit further towards the north, and a lot of that precipitation ended up falling on our land areas in Cape Breton and eastern Nova Scotia. So for a number of days, we knew that there was a potential for heavy rain. We just did not think it was going to happen exactly where it ended up happening. But again, that's the whole communication part of it. If people know that there's a potential for 200 millimeters just 50 kilometers offshore, you're probably still going to take some sort of preparation in case that comes up. So it's not a situation of this came out of nowhere. We had the signs were there early on. It was just that the challenge was communicating those signs to people so they could take action.
Thank you for that. We actually have another question now. Yeah, the attendee thinks this is a great presentation. I agree. Would you be able to comment on the resolution in the ECCC data on hurricanes? The attendee is just wondering if it's possible to use this information to capture wind and storm surge hazards for local buildings and portfolios.
Yeah, basically there is what we call the HERDAT database for tropical cyclones in the Atlantic. And it's basically a huge data set that is managed by a group at the National Hurricane Center in Miami. So when we look at past storm events, we're basically using that, it's called HERDAT data set. And if you Google HERDAT, HURDAT, you will be able to download a file that basically has all the intensity and positions and the times of all the tropical cyclones dating back to the 1800s. There's not a whole lot of information there, however, on specific to storm surge. We do have some data that pertains to storm surge, but based on the sparse tide gauges that we have, there simply is not a whole lot of information on, or climatology, if you will, on storm surge here in Canada just yet.
Okay, thank you for that. I think these are all the questions. I just want to thank you again, wondering whether you have any final comments to make. Thank you for the forecast. It seems a bit better than last year, so we're looking forward and hoping that will be the case moving forward.
Yeah.
Do you have any last comments?
Yeah, no, it's just, as we head into hurricane season that starts on Tuesday, luckily it does look like what we saw last year is probably not going to repeat itself, but that prediction of 20 named storms is still a significant amount of storms. And at the end of the day, it only takes that one bad one to make it a bad year. So we have to prepare the same way every single year.
Certainly does. Thank you so much again. And thanks to all those who attended.